quite a few celestial events in the next couple days. We have winter solstice, the Earthside meteor shower, Mercury's greatest western elongation, a new moon, and Jupiter's station. Now, winter solstice occurs on December 22nd at 5:30 a.m. GMT. So once you convert that to your own time zone, it could be on the 21st or 22nd, depending where you live. So winter solstice is the sun's ingress into tropical Capricorn. And to understand why the Earth's seasons correlate to the tropical zodiac, I'm going to introduce two great circles, the celestial equator and the ecliptic plane. Here is the celestial equator, this red line, and this is the ecliptic plane. Now I'm going to come back to this image in a moment, but first I want to do this one. This is a drawing that I did in paint. We've got the celestial equator is this thick green line here, which is Earth's equator extended out into infinite space. And then if you have ever seen a globe, you will have noticed the tropics of Cancer and the tropics of Capricorn, which are located at 23.26 degrees north or south of the celestial equator. And this is because that is the Earth's tilt on its axis. The Earth is tilted at 23.26 degrees. So in this diagram, this wavy line here is going to be the ecliptic plane. This is the path that the sun traces in our sky. It's the apparent path of the sun because, of course, Earth is spinning and the sun is still. But what happens is where the ecliptic and the celestial equator intersect, we have an equinox. When the sun reaches its maximum declination, which is the north and south measurement from the celestial equator, it reaches its maximum declination of 23.26 degrees north, and that's when we have summer. When it does that in the south, that's when we have winter. And here again is another equinox. So we have two equinoxes, and we have two solstices that happen due to the interplay of these two great circles. And here's another image I have of how the Earth's tilt comes into play. So you see here at winter solstice, which we are about to experience, the way that the Earth's axis is tilted, the sunlight is hitting more on the southern hemisphere. At summer solstice over here, the sunlight is hitting more on the northern hemisphere because of the way we are tilted. And here at the equinoxes, the sun is more directly at the equator. Now, to further illustrate how the sun's declination at different times of year plays into the sun's height for the year, I have this, one of my favorite diagrams, of how if an image of the sun was taken over several days of the year and superimposed all into one photograph, the sun would trace out this figure 8 in the sky. This would be winter solstice in the northern hemisphere with the sun at its lowest point, and summer solstice with the sun at its highest point. And over here is going to be both the height of the sun at both the autumn and the vernal equinox. So let me show you this in the program so you can watch these different heights. So I have this for noon because we really want the sun to be up. So I've set this for noon on December 21st. So at noon, you know, the sun is pretty much due south. And it's high noon because that's the highest the sun reaches in the sky. So what I want you to notice is that the separation between the celestial equator and the ecliptic plane is at its greatest here. This is a 23 degree and 23.26 degree difference between these two great circles. And the sun is very low in the sky. Now watch what happens when I go to March at noon. And here we go. The sun is now at the intersection of the celestial equator and the ecliptic plane, and it's higher in the sky than it was when it was down here at winter solstice. Now I'm going to move this to summer solstice, And now you'll see that the ecliptic plane this time is above the celestial equator. And this again is its greatest distance between the two great circles, and the sun is yet again higher in the sky than it was at the equinox. And then when I go back to the autumn equinox, here we are again at the intersection of these two great circles, and the sun has begun its descent in the sky. So hopefully that helps make sense of the height of the sun and the seasons for you. Now, our next celestial event occurs on December 22nd, and we need the skies to be dark. And what we want to show up is we want to watch the Little Dipper, because this is the Earthside meteor shower. Now, the Earthside meteor shower is actually active from December 17th through the 26th, so it is possible to see shooting stars during this time. The peak, however, occurs on the night of December 22nd and into the dark hours of the morning of Friday, December 23rd. Let me go ahead and give some guides of these constellations so that you can see what's going on. And now we're going to have to face north to see the dippers. Okay, so here we are. Here is the north view of the sky at 6 p.m. on December 22nd. This is Polaris, our North Star. This is the Little Dipper, the Little Bear, Ursa Minor. And the shooting stars are going to come over in this area, okay, like they're spilling out of this cup. Okay, now the radiant of the shooting stars is what the meteor shower is named after. So this Earthside meteor shower means that the radiant of the shower is in the constellation Ursa Minor. And being that this is a circumpolar constellation, because this is our North Star, right, it sits relatively still in the sky. As I advance this through the night, we're going to just watch this turn a circle. We're going to watch a sky turn the circle as if Polaris is still. So I'm going to do that for you while I talk about the meteor shower. I'm just going to advance it hour by hour. So now the Earthside meteor shower occurs as Earth passes through dust and debris that is left behind by the parent comet 8P Tuttle. So as it passes through, it's going to pass through from December 27th to 26th, but it passes through the most dense area of the comet's trail on the 22nd, 23rd, which is why we're going to see the shooting stars then. And of course, shooting stars are not really stars. Okay? What they are is this dust and debris from the comets that is entering in our atmosphere, and when it enters our atmosphere, the Earth burns it up. So the streaking that we see is what provides the shooting star effect, and experts say that we can witness about 10 to 50 meteors per hour at the peak of this Earthside shower. So our next event is Mercury's greatest western elongation on December 23rd. So if Mercury is traveling west of the sun, it is going to rise first. So let's change this here to 7 a.m. We're on the 23rd. We need to go back and face south to see the ecliptic. And sure enough, there's Mercury above the horizon. Now on December 23rd, Mercury will reach a distance west of the sun of 21.84 degrees. Now just because Mercury can travel up to 28 degrees from the sun at each of its elongations, it doesn't mean it's going to go that far every time. And if you want a detailed explanation of Mercury's greatest elongations, its inferior and superior conjunctions and retrogrades, see my previous blog from November 18th to 24th, where I used a video of the inner solar system to explain this in detail. Now I'm going to get on with the sky tour for us, and I might as well start here with the morning sky and Mercury. I'm going to go back to the 21st, 7 a.m. Now here we see Saturn and we can see Mars. Now Mars is rising before 11:30, Saturn before 3, and here's Mercury. And Mercury rises at about 6 a.m. Okay, Saturn rose at 2:45, Mercury at 6 a.m. I'm going to leave this view so you can see all of the planets. And here's the moon right here underneath Zubin el-Ganubi on the morning of the 21st. As I go to the 22nd, you can see that Mercury here is just left of the moon. Now, Mars is going to move some. You can watch Mars move from about this area of the sky to this. There isn't a bright fixed star here to track. We're going to be able to notice it because we have this constellation line, but you may be able to pay attention to how close it is to Denobula as you watch Mars's movement. Saturn's going to move a titch, not very much. Mercury, however, is going to make some significant movement, and we're going to watch Mercury pass up Antares. This is Scorpio here, this constellation. This was Libra, this is Virgo, there's Leo. Okay, so here is the morning of the 23rd, and now Mercury is above the moon because the moon's traveling like over 13 degrees a day. Here's the morning of the 24th, 25th, Christmas morning, 26th, 27th, 28th, see Mars is past here. Here we're getting Mercury's getting very close to Antares, 29, 30, 31, and by the new year here Mercury has passed up Antares. So now what I want to do is go back to the 21st and switch us over to an evening sky view. Okay, so here we are in the evening sky. This is at 7 p.m. Venus is about to set. She'll set a bit later each night. By the end of the month, she'll be setting around 7:30. Now as the skies darken, and they're going to get dark pretty early, I mean here we are at 5:30. At 5:30, even though it's still a bit light, you can still see Venus and Jupiter, and perhaps even a couple stars. Fomalhaut may pop out if your city lights aren't in the way, and also Altair. This is of Pisces Australis, and this is the Eagle. So you're going to find Jupiter above the east-southeast horizon and Venus above the southwest. We got a southeast and a southwest. I'm going to advance this a bit so we can watch Venus's movement with some more stars in the sky. Okay, here's 6:30. And let's watch Venus move through the constellation of Capricorn. Here's the night of the 22nd, the 23rd, the 24th, it's Christmas Eve, 25th, 26th. On the 26th, you'll see Venus just left of a crescent moon, the new moon occurring on the 24th. Here's the 27th. Now the moon has moved past Venus, and Venus is below the moon. It's the 28th. No, not quite yet. There's the 28th, 29th, 30th, 31st, and the moon will make it nearly to Jupiter by New Year's Day, by the evening of New Year's Day.